Yes. Uh, in many cases, you will find x is equal to tan theta. Here also, if you remember the formula of, still I am telling you the formula that we have done in class 11. Tan 3 theta is equal to 3 tan theta minus tan cube theta, tan cube theta divided by 1 minus 3 tan square theta. So you can see here 3x, if just in place of tan theta here it is x. So obviously we have to put, first we will start from, we have what we have given y is equal to tan inverse 3x minus x cube divided by 1 minus 3x square. We have to find the derivative dy by dx. So here you will do the trigonometrical substitution. Put x is equal to tan theta we get we are just substituting, not differentiating now. We are reducing it into the simplest form by using the trigonometrical substitution. 3x is replaced by tan theta. So 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. After today, you have every Thursday 11 to 12:30 class. But if need, I will extend that class, or I can take more classes, but at least one class will be there in a week. So this formula will become tan 3 theta. Correct? So our aim, as I told you, our aim is to make tan theta here. So that tan and tan inverse will cancel. Tan and tan inverse will be cancelled, and we get not in holidays now. Mudassir, not, no, 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 no. Just attendance I need for extra classes. Yes, I need how many, pending how many are not. So 10, yes, y is equal to, sorry, I forgot to write here a very important thing, inverse. So that's why this inverse will cancel. We get 3 theta. And theta is tan inverse x. Theta is what? Theta is equal to tan inverse x. So here we will substitute again the value of theta, 3 tan inverse theta. So this is reduced. What we have done? We have reduced it to very easy form in order to differentiate. Now we can differentiate with respect to x, differentiate with respect to x. We get dy by dx is equals to 3 is constant. So d by dx of tan inverse x. So tan inverse x is 1 by 1 plus x square, I told you. You have to remember that formula is 1 upon 1, 1 upon 1 plus x square. So we get the answer 3 upon 1 plus x square. Okay. So whenever it is very clear, formula is fitting like in question number 11. But sometimes we are not getting direct formula. For example, here we need 10. Sometimes we can get cot and then we have to convert into 90 minus theta. So question number 11, so I am leaving. You can put same tan theta. So for 11 question, you can have this formula after putting tan theta cos 2 theta. This formula for question number 11, you will put x is equal to tan theta and use the formula for cos 2 theta. Cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. Okay, so that is direct substitution. Question number 12. I'm taking now question number 12 of this exercise 5.3. So question number 12. Yes, this is question number 12. Now here again, this, if you see, this is the formula for cos 2 theta. In 11th also we did this, but here outside is cos inverse, so it will be solved. But what will you do here? So we can put, we have given sine inverse 1 minus x square upon 1 plus x square. Okay. So again put x is equal to tan theta. We get y is equal to sine inverse 1 minus tan square theta on 1 plus tan square theta. And 1 plus tan square 1 minus tan square theta is equal to cos 2 theta. So we get cos 2 theta. And instead of getting sine, we get cos 2 theta. So no problem. This cos 2 theta can be converted into tan theta by 90 minus theta. So sine 90 minus theta, or you can say that cos 2 theta. Yes, cos 2 theta can be written as sine 90 minus theta, pi by 2 minus theta, sine 90 minus theta. Here 2 thetas, sine 90 minus 2 theta is equal to cos 2 theta. So we can replace this cos by sine, so that this sine inverse will be cancelled. So we get sine pi by 2 minus 2 theta. Now this sine will cancel. We get, finally it is reduced to pi by 2 minus 2 theta. But theta is again theta is from here, tan theta is equal to x, then theta is equal to tan inverse x. So here we will get pi is equal to, after this we get y is equal to pi by 2 minus 2 tan inverse x. Now differentiate with respect to x. Differentiate with respect to x. So we get dy by dx, and pi by 2 is a constant number. You can write and then you can put 0, its differential will be 0. Then minus 2 will be there, and dy by dx of tan inverse x. And definitely tan inverse x is equal to 1 upon, so minus 2 upon 1 plus x square is the answer. So sometimes it also happens that we are not directly getting. Similarly, in question number 13 also, we will put tan theta. In 14, I will do. Question number 13, 11, also tan theta. Question number 13, also you will put tan theta and sine 2 theta formula will be used, then 90 minus theta will be used. So you can do question number 13, you can try. Okay. So I will take question number 14, 15. That's it. No? So question number 14, 15. Question number 14 and question number 15. So in 14 question, in question number 14, y is equal to sine inverse 2x the root 1 minus x square. So here it is different. Here we will put x is equal to sine theta, or we can put cos theta also. So put x is equal to sine theta, because 2 sine theta cos theta will become sine 2 theta. That's why you put x is equal to sine theta, we get sine inverse 2 sine theta under root 1 minus sine square theta. Under root 1 minus sine square theta is equal to cos theta from trigonometrical identity. So you can write 2 sine theta cos theta, and 2 sine theta cos theta is equal to sine 2 theta. So we can write sine inverse sine 2 theta. Sine and sine will can sine inverse and sine we cancel, we get 2 theta, and now theta will be equal to sine inverse x. Theta will be equal to here sine inverse x. So substitute this value of theta here. We get y is equal to 2 sine inverse x. Now differentiate with respect to x. Both sides differentiate with respect to x. So we get dy by dx is equal to 2 is constant. The 2 is outside. We will write d by dx of sine inverse x, and differential of sine inverse x is equal to 1 upon under root 1 minus x square. Okay. Then we have question number 15. Y is equal to sec inverse 1 by 2x square minus 1. So we have to bring sec or cos. So 2 cos square theta minus 1 is cos 2 theta actually. Cos 2 theta is also equal to 2 cos square theta minus 1. So we will put cos theta is equal to x is equal to cos theta. So here you can put x is equal to cos theta. So we get y is equal to sec inverse 1 by 2 cos square theta. X is replaced by cos, so 2 cos square theta minus 1. Because we will get 1 upon cos, and 1 upon cos will become sec theta. So it can be solve. So then 1 by cos 2 theta. This will become cos 2 theta. And 1 upon cos theta is equal to sec theta. So this will become sec inverse sec 2 theta. Sec and sec inverse will cancel. We get y is equal to 2 theta. And from here you can see theta will be equal to cos inverse x. This value of theta you have to put here. We get y is equal to 2 cos inverse x. It is simplified. Okay. Now differentiate. After this you have to differentiate both sides with respect to x. Differentiate with respect to x. We get left side dy by dx and right side x. 2 is constant, so constant will come out from the derivative. We will find the derivative of cos inverse x, and derivative of cos inverse x is equal to minus. So this will become minus 2 on under root 1 minus x. So like this, if you have the questions based on trigonometry, then you can have. Now we have already studied for the next exercise the types where we were using previously also quotient rule and some standard formulas. So we can, I think, go ahead for the next exercise 5.3 directly. Because 5.3 only the added one thing is uh, cos log formulas that you know that cos differential of e to the power x log x we have seen already. Already we have seen everything, so we can start exercise also. All the formula that we already studied will be used here again. So 5.4, I will take some questions. You have to see that which is having t substitution, which will be solved by first quotient rule. You can see the question number 1. It's very easy. It is just like quotient rule. Y is equal to e to the power x upon sin x. Differentiate. So we will do d by dx of both sides. D by dx I have started directly. You can write let and everything. So d by dx. Now you have UV rule. So denominator. So therefore we have dy by dx is equal to denominator. You have to leave always denominator in this formula. Then differential of e to the power x minus leave u e to the power x and differential of denominator d by dx of sin x and the square of the denominator sin square x. Sin square x. Just solve it. Sin x differential of e to the power x is equal to e to the power x minus e to the power x. Differential of sin x is cos x divided by sin square x. Then you can take out common e to the power x. So your final result is e to the power x into sin x minus cos x divided by sin square x. So it was a simple question. But if you see question number 2, this is question number 2 we have done first. Y is equal to e to the power sin inverse x. This is just first differentiate with respect to x. Dy by dx will be equal to d by dx of e to the power sin inverse. This is a t substitution chain rule. So chain rule outermost, what will you write first? E. First we will write e, then sin inverse x. So the outermost function is e. So differential of e is d by dx of e to the power x is e to the power x. Correct? E to the power x is e to the power x. So differential of e to the power x, e to the power. So e to the power sin inverse x. Then Go inside. So inside you have function sine inverse, differential of sine inverse x. E to the power sine inverse x as it is. Differential of sine inverse x is equal to 1 upon under root 1 minus x. So you can also write e to the power. So we got e to the power sine inverse x divided by under root 1 minus x square. So it is a chain rule. Again, question number 3 is also a chain rule. Question number 3 is also a chain rule. That is, question number 3 is again y is equal to e to the power x cube. It's simple. E is the outermost function, so dy by dx of e to the power is e to the power x cube. I'll write directly, then d by dx of x cube. Okay, so x cube is differential of x cube. That is the first formula, x to the power n x and minus 1, 3x square. So our answer is 3x square into e to the power x cube. So these are very simple type of questions in our textbook. T substitution, wherever you have to apply T substitution means chain rule, wherever you have to apply the quotient or product rule. So you should take care about it. This is just what we have here. Question number 4, same exercise. Y is equal to sine. Outermost, what I am writing first, sine. Then tan inverse. Okay, tan inverse. Yeah, this looks like tan inverse. Then e to the power, then minus x. Minus x is also another function. This is not e to the power x. Minus x will be differentiated. There are 1, 2, 3, 4 functions. It has how many functions? 4 functions. Which is the outermost sine, then tan inverse, then e, then minus x. So we have to differentiate all functions. So first I will differentiate sine. dy by dx is equal to differential of sine is cos. Cos, and inside functions as it is, we used to write tan inverse e to the power minus x as it is. Then we have to differentiate dy by dx of tan inverse. We have to differentiate dy by dx of tan inverse e to the power minus x. E to the power minus x. So 10, that is the last outermost. So that will be differentiated cos. We will write as it is this one, tan inverse e to the power minus x. And this tan inverse, the differential of tan inverse is equal to 1 upon 1 plus x square. 1 upon 1 plus x square. So x is what? E to the power minus x. So e to the power minus x whole square. Then go inside. Now you have to differentiate e to the power minus x. Minus x again we have to differentiate. This is minus x, not x. If it is x, e to the power x directly. But e is the outermost, inner is minus x, will be differentiated again. So we get cos tan inverse e to the power minus x. Then e to the power minus x. This denominator I can write here. 1 plus this 2 will go inside. We can write e to the power minus 2x. Then e to the power. What is the differential e to the power x? Is e to the power x. So e to the power minus x. And then again differentiate. Don't leave this. Generally they are leaving the last. If it is minus x, you have to differentiate minus x. and minus x, differential of minus x is minus 1. So that is why we have negative value of minus x into, we can write e to the power minus x first, cos tan inverse e to the power minus x divided by 1 plus e to the power minus 2x. Okay. So we have to see how many functions are there. I can see here how many functions are there. 3 functions: log, cos, and inverse. So we have to differentiate 3 times. You can see this first time I have differentiated directly cos. Second time tan inverse. Third time e to the power minus x. Fourth time this. So whatever number of functions are there, you have to differentiate that many times. Here, this question number 5 you can try. Your sixth question is having all values in summation e to the power x square, then plus e to the power x cube. It is not written, but we have given that e to the power x cube, then e to the power x raised to power 4. We have to take each and every question, each and every, sorry, not question, each and every part of this question, x raised to power 4 plus e to the power x raised to power 5. This is not the dotted one way. Every function will have different differential, that's why. So you cannot do by dotted line. Now differentiate, it is very simple question, but you should know how many times you have to differentiate in each case. So when you differentiate, always write, please here I am not writing, differentiate with respect to x, always write differentiate with respect to x. I will also write. So d by dx will go inside. First of all, d by dx into this function, then d by dx go inside. So that steps also you should write because you are in the beginning of differentiation. So d by dx of e to the power x square, it has two functions, e and x square. This has only one function, e to the power x. Okay. And here also you have two functions. One is outermost function is e to the power x and inside is x cube. So two functions, exponential and x cube. Here also you have two functions. So I think now you hope you understood. Now you can do it directly also, x raised to power 4. If you practice more, you can do it directly. Now we will do it directly without writing each and every step like this. I have written, I can write directly the answer of this one. See, I can write directly answer of this. How? Sine cos tan inverse e to the power minus x. Then into tan inverse 1 upon 1 plus e to the power minus x whole square. Then e to the power minus x, e to the power minus x. Then differential of minus x is minus 1 and multiply, you get the answer. So like this you can write, but there are chances of doing mistake for you because you are in the beginning of this one. So that's why I avoided this one. But later on you can do it. So e to the power x is to the power 5. Now it is e to the power x is e to the power x. But here you have two functions. So I will write directly e to the power x, e to the power x square. Then differential of x square is 2x. Okay. Similarly here differential of e to the power x, e to the power x cube, and differential of x cube is 3x square. Similarly differential of e to the power x raised to the power 4, x to the power 4. Differential of x to the power 4 is 4x cube plus e to the power x to the power 5 into differential of x to the power 5 is 5x to the power 4. Plus, now you can write it like means in a standard manner, e to the power x square plus you are getting 3x square e to the power x cube plus 4x cube e to the power x raised to power 4 plus 5x raised to power 4 e to the power x raised to power 5. This is your answer.